students. In this session, we have the discussion about some terms involved in the economics of the power plants. Whatever may be the manufacturing, the economics is a vital role in deriving the profit in a certain manufacturing sector. So for the longer years, there have been many techniques and technologies developed for the economic power generation. So the aim of the power plant design is ultimately based on the economical condition rather than on efficient condition. So the primary objective of any power plant, whatever may be the drive, whether it is steam driven or gas driven or hydraulic driven, objective is to generate the electric power at the minimum cost. So for cutting down the generating cost, efficiency also is a important factor to be considered. So unfortunately, the most thermally efficient plants are not economically feasible. It's very unfortunate. So now let us look into some terms involved in the economics of the power plant. First is the connected load. So here the connected load refers the combined all the ratings of the equipments connected on a particular consumer premises or industries totally. So it is connected load. It is a continuous power rating of all the electric appliances in a premise of consumer or industries, any other thing. So it is connected load. Second term is the demand. Here demand is the load which is drawn from the source of supply at the receiving terminal in a specific interval of time. The demand is the load that is drawn from the source of supply at the receiving terminals over a suitable and specific interval of time. So the demand normally expressed in kilowatt or kilowatt ampere. Next is the maximum demand, or it can be frequently called as peak load. So here it is the highest value of the electric power demand that have generated over a given period of time from a power plant. So it is a maximum electric power demand that is generated over a certain period of time. So it is normally indicated over a period of prescribed time, maximum demand or peak load. Next, demand factor. So the demand factor is the ratio of the maximum power demand to the connected load. It is a ratio maximum power demand and a connected load. And next, load factor. It is a load ratio of the average load and maximum demand of a power plant. Here, the average load is indicated in the regular interval. So the interval is indicated, and maximum demand. So the maximum demand also expressed in a specific period of time, because it's half hourly monthly load factor. So accordingly, the load factor is called here. The maximum load, interval of maximum load is expressed, and also the period over which the maximum demand is expressed also noted in the load factor. So accordingly, the load factor is called. Next, plant capacity factor. The term compares the energy generated of a power plant to the maximum possible energy that have been developed or generated by the power plant for a given period of time. Here, so it is given as the ratio of the energy generated in kilowatt hour, that is unit, to the maximum possible energy that have been generated during the same period. Here, T indicates the total number of hours in the given period. Here, the T, here, total number of hours in the given period, it includes also the off time, where when the plant is not in operation. So whatever may be the condition, whether it is working or not, it includes total hours for the given period. So it is a ratio of the actual energy generated to the maximum possible energy that have been developed or generated. Next is the plant use factor. Here it is almost the same as the plant capacity factor, but the only difference is instead of considering the total hours, here it considers only the hours when the plant has been in operation. So it considers the number of hours when only the plant is in operation. So it is indicated by T dash. All others are same. So plant use factor is the types of load. So residential load, as we know, the electric appliances are applied in our homes, electric cooker, refrigerator, heater. So these are the connected load. So these are come under the residential load. Commercial load. Commercial establishments are coming under this category, and industrial load. Then municipal load. So street lighting, sewage treatment, drainage purpose, these are come under the municipal load. Traction load. So for the public convenience or transportation, car, trolley, buses, trams. So for which the power is used, so it comes under the traction load. Next term is the load curve. It is a graphical plot between the electric power demand and the period of time. So it is a graphical plot between the electric power demand and the period over which the load curve is considered. So the time period may be 1 hour. So if it is drawn for the 1 hour, the load curve is called hourly graph, hourly load curve. If it is for 24 hours, it is the plot is made. So the graph is called a daily load curve. But if the same is plotted for 1 year, 8760 hours, it is yearly load graph. So next is we can look into the load curve. So in the y-axis, it is plotted as the power demand. In the x-axis, time. So from which we can easily infer the maximum load, that is a peak load, and also the base load, and in between them, the average load. Here is a graphical plot between the power demand and the time. Here, some information that can be drawn from the load curve. So the area under the curve represents the total energy generated over the given period of time. Area under the curve indicates the total energy generated. Next, the area under the curve divided by the total number of hours gives the average load of the particular power plant. Here we can easily identify the peak load of the plant. Easily can be identified. Next, what are the significance of the load curves? So the curve gives the exact information about what is the incoming load that is being generated, and by the data we can decide what are the capacity of the each units in a plant, and we can decide the the sizes of the various generating units economically. And also, it can be used for estimating the cost of generation of the electric power. And also, we can schedule the different operation of the different units in the same plant. Next, the term is the load duration curve. It is also similar to the load curve, but the only difference is the demand is set in the descending order for a given period of time. So it is set chronologically. So it is also called a chronological load curve. So the diagram shows clearly the daily load curve and the load duration curve. So the above diagram shows the load curve for 24 hours from 6 to 6 p.m., 6 a.m. to 6 p.m. Sorry, 6 a.m. to 6 a.m., 24 hours. And here the maximum demand is 35 kilowatt. So here for low duration curve, first the maximum demand is first considered. So 35 kilowatt. So the 35 kilowatt is for the time period of 6 hours. That is 8 a.m. to 2 p.m. That is 6 hours. Next, smaller power demand is 30. So it is for 3 hours. So here from 6 hours to 9, that is 3 hours for 30 kilowatt. So similarly, all the power demand is set in the descending order. Here the area under the curve does not change between the load curve and the load duration curve, because the power demand and the time duration is not altered. So what are the information that can be inferred from the load duration curve? Area under the both curves, load curve and the load duration curve, is similar and equal. And it gives us clear picture of the analysis of the generating power economically. So these are the terms involved in the power plant economics and the principle of power plant design. So there are some factors to be considered for the efficiency of the plant design. So the methods to be adopted is simplicity of design of the layout and all the units, and low capital cost, low cost of energy generated, higher efficiency, maintenance cost is at minimum, low operating cost, reliability of supplying power, reserve capacity to meet the future demands. So in this session, we have some introduction of the power plant economics and also the terms involved in the economics of the power plant, because the terms frequently involved in the various aspects dealing with the economics of the power plant, and also the analysis and the problem involved in the economics of the power plant. So thank you, students.